Okay, so now we're going to find the angle between the pair of vectors. And in a previous video, we talked about using the dot product to find the angle between two vectors. But let's take a look at this right here, and I'm going to highlight it. The dot product of two vectors uv is defined by the product of their magnitudes multiplied by the cosine of the angle in between them. So what we get when we're trying to find the angle between two vectors is something that looks like this right here. Okay, so when you manipulate this formula, if you take the dot product of uv divided by the magnitude of u times the magnitude of v, you'll get the cosine of theta. So we're going to use this concept here to figure out the angle between two vectors. We're going to start off first looking at number 14, and let me go ahead and write that out. Okay, so we've got -9 and -7, and we've got -8 and -7. Okay, and so what we have to do is we first find the dot product, u dot with v, then we're going to have to find magnitude u and then magnitude of v. So this is kind of the steps that we need to do in order to come up with the cosine of the angle, and then we're going to have to take a cosine inverse. Okay, so let's see, u dotted with v, what does that look like? That is -9 times -8, okay, because remember, A, B, C, D, it's AC plus BD, so plus a -7 times -7, okay, and what do we get? We get 72 plus 49, let me erase that right there real quick, 49, and that is 121. Now we're going to find the magnitude of u. We're going to find the magnitude of u, and in doing so, this is like the Pythagorean theorem, and it's relatively easy. Just be careful and don't forget that if you have negative numbers, put them inside parentheses. Okay, so that becomes the square root of -9 squared, which is 81, plus the square root of plus a -7 squared, which is a positive 49, and that becomes 81 plus 49, a square root of 130. And don't worry that you don't know what a square root of 130 is. It's not perfect. Just leave it like that, because we're going to utilize our calculator in just a second. Okay, so let's now find the magnitude of the vector v. And again, another play on the Pythagorean theorem here. -8 square plus a -7 square, and you take the square root of that, and you're going to get, so 64 plus 49, okay, and that looks like a square root of 113. Okay, so we've got that going for us. So now we are going to write out the formula for the cosine of theta. All right, it is u dotted with v divided by the magnitude of u times the magnitude of v. All right, and we're going to basically plug in our numbers. So the dot product is 121 divided by the square root of 130 times the square root of 113. So you'd plug that in the calculator and you get an approximation of 0.998. So we can say the cosine of the angle theta is equal to 0.998. But that does not give us the angle of the angle between the two vectors. So in order to do that, we would have to take the cosine inverse of 0.998. All right, and you do that right there, and then you get something that's approximately 3.3 degrees. Now remember, when you're doing this on your calculator, that you need to have your calculator in degree mode. Okay, so keep that in mind. Okay, now the next example here is number 15, and we're going to take a look at that, and that'll be the last example here. It's an interesting problem. It says 8i plus 2j negative 6i plus 7j. So I'm going to jot that down first. Give me 1 second here. All right. Number 15. It says 8i plus 2j. It actually should be a j, not an I. Okay. Let me fix that. Okay, there we go. That's the first vector, and negative 6i plus 7j. And again, I don't know why I'm writing i's. Okay, so in another video, we discussed the unit vector, I and j. So what in the world are I and j? I is this vector, and it's the unit vector. It's a vector with a length of 1, a magnitude of 1. And in this case, it's the I represents 1, 0, and the j vector represents 0, 1. So these two vectors look almost the same, except this one vector here is a horizontal vector with a length of 1 unit, and then this one is a vertical vector with a length of 1 unit. But otherwise, it's not too difficult. We're just going to plug in what we know. It's a little bit more work than the last problem, but it's easy to figure out once you get the hang of it. Okay, so let's take a look at the 8i plus 2j first. So 8 is going to be a scalar multiple of I, which is 1, 0, plus 2 scalar multiple of 0, 1. Okay, and then we're going to have over here negative 6 times as a scalar multiple of 1, 0, plus 7 as a scalar multiple of 0, 1. Okay, looks something like that. Now let's go ahead and do the scalar multiplication. We're going to get 8, 0 plus 0, 2. And when we combine that, we're going to get 8, 2. Very simple. Okay, we add those vectors right there. Okay, and then over here, we're going to get negative 6, 0. And we're going to get 0, 7. And when we bring that together, we get negative 6, 7. Looks something like that right there. Okay, so this is the vector u, and this is the vector v. Okay, so not much to it there. All right, now what we have to do is find the dot product, u dotted with v. Okay, so let's see, what does that look like? That's 8 multiplied by negative 6 plus 2 multiplied by 7. Negative 48 plus 14, which gives us a dot product of negative 34. And now we find magnitude u. Again, a play on the Pythagorean theorem. The square root of 8 squared plus 2 squared, which is the square root of 64, plus 4, which is the square root of 68. Okay, and then magnitude v, which is going to be the square root of negative 6 squared plus 7 squared. Lost my train of thought there for a second. 36 plus 49, which will give us a sum total of 85. So the square root of 85. So we've got the three things that we need now to plug into our formula. Okay, so let's recall the formula again. The cosine of theta equals u dotted with v divided by the magnitude of u times the magnitude of v. All right, and so the cosine of theta in this case will equal, and let me readjust it here for you. The cosine of theta will equal, let's see, negative 34 divided by the square root of 68 and the square root of 85. Okay, so we do that on our calculator. You're going to get some approximation that's about, negative 0.447. So then you take the cosine inverse of negative 0.447, and you get something in the ballpark of 116.6 degrees. So this is the angle between these two vectors. Okay, so a lot of work here to come up with what looks like a real easy answer, I know. But everything in this section has kind of built up to this moment, and this is kind of the height of where the complexity gets for this section. So if this video was helpful, you understood it, surely come back and watch the videos, but like and subscribe.